is from Greece and Norway, and it will be presented by Zacharoula Papamitsiou. So.
Good evening, everybody. I am Zacharoula Papamitsiou. I come from Greece. I represent the University of Macedonia located in Thessaloniki. Today I will present to you a work that we done with our colleagues in Norway, the team from NTNU. And our research is about employing FsQCA method for explaining learning performance using response times, self-regulation, and satisfaction from content. So, until now, traditional methods have explored scores and grades for explaining performance, but both scores and grades have the problem of being unreliable because they may distract people from deeper learning, or because they doesn't necessarily reflect mastery, or even because they are conducive to cheating. For this purpose, researchers have also searched for other factors that explain performance, including motivational factors and self-regulatory strategies, including content validity and student satisfaction from the content, response times and correctness of the answers, backgrounds, and personalities, and many other things. But the question still is why students act the way they do, and how their actions and scores reflect what they really know, and how can we get a more concise interpretation of their performance. Response times in the past have been associated with learning motivation and guessing behavior, and it was found that if we directly tried to explain performance based solely on response times, that would lead to insignificant results. On the other hand, when these response times are related to motivational factors, for example, the results are promising. Moreover, response times are also associated with pacing and time management in terms of self-regulated regulatory strategy. And it was found that high-achieving students are mostly students with high time management skills and, in general, with high self-regulatory skills. Moreover, student satisfaction from content has been associated with learning performance, and it was found that if the students perform that the content is understandable and clear, then they are more likely to perform high. However, as I said before, examining these factors solely, exclusively, can be unreliable to explain performance. So, which combinations of these factors could be could lead to significant results and could better explain the obtained results? Most studies until now have been employing variance-based models, and they examine net effects like regression models. However, these methods have three drawbacks, including that they are likely to be symmetrical. The relationships identified might be symmetrical. They only identify one solution for the problem, and the symmetric solutions might be misleading and do not apply in all cases in the dataset. For this purpose, the Venn diagram here visualizes somehow and not quantifies, let me say, a conceptual model that includes the three basic factors and their possible combinations regarding explaining the performance. In this diagram, we have used the three basic factors that I explained before. I mean self-regulation, which was measured like time management and goal expectations. We also used satisfaction from content in terms of perceived clarity from the content. And these two variables, I mean self-regulation and satisfaction, were perceptions measured with questionnaires. And we also used response times, which are actual data, and we discriminated these two in time to answer correctly and time to answer wrongly. For identifying the combinations of these variables that would result to explaining the variable of interest, which is the performance, we used a combination of complexity and configuration theory, which has two basic principles. The first one is that there are more than one solutions, more than one combinations of the variables that explain the outcome. This is what is called equifinality. The second principle is that asymmetrical relationships can be identified. And let me give you an example of that to make it clear. As I said before, research has shown that if a student has a good time management skill, it is more likely to be a high performer. The symmetric explanation of this relationship is that a student with low time management skill is expected to be a low performer. However, an asymmetric relationship would be that a student with high management skill still could be a low performer. So we had an exploratory study for investigating these relationships, and 452 participants participated in a self-assessment test. The test duration was 75 minutes for each group of participants, and we had 60 items, 60 questions in total. The parameters, the measures that we used was the ones I said before, and this is the way we actually took the measurements. Self-regulation and satisfaction from content are measured via questionnaires, and the other two via actual measurements from the track data. Because we have latent variables, we checked for reliability and validity in these measurements, and we confirmed the validity of the measurements. And then we used FsQCA, which means fuzzy set qualitative comparative analysis, for identifying the relationships, the effects. FsQCA identifies patterns of elements between independent and dependent variables that lead to an outcome and may complement and extend previous regression-based models. I will come to that later. So the results of FsQCA analysis are summarized in this table. And before explaining the results, I would like to explain you how to read this table. There are two basic measures, which are consistency and coverage. Consistency is how strong are these results, the identified solutions, and they have to be higher than 0.8. In our case, it was 0.81. The coverage is something like what we call R-square in regression-based models, and explains how much of the sample is explained by the solutions provided. The second thing that we have to notice in these results are the symbols. The black circles indicate the presence of a condition, and it means that this variable has high values in this condition. And the circles with the X represent the absence of a condition, and it means low values for the respective variable. There are also blank spaces which represent the don't care, which means that this variable has no effect on the solution. There are also small circles which indicate peripheral effects, which means that they participate, but their effect is not strong. Okay, so for high-performing students, we identified 5 solutions. the one that is the most possible to be detected by regression-based models is the one identified here with the red square. And this explains 40% of the sample. And according to the results, students with high satisfaction from the content and high self-regulation skills are high performers. This is a relationship that if we took the negation, we would expect that students with low perception of the clarity of the content, those who don't understand the questions, and those who have low self-regulatory skills would be low performers. However, as will be seen here, this relationship is not identified. Another relationship identified as those of high-performing students is this one, which is quite interesting. In this result, this solution, we found that students with low goal expectations and low time management, who, however, aggregate a lot of time on answering correctly, are high-performing students. So it's more about giving the right answer and thinking about what you submit, rather than being having self-regulation skills. In a similar way, we identified solutions for low-medium performing students, which means non-high performing students. A typical example of these students, and the one that explains the most of the sample, 58% of the sample, is the second solution, which says that students with low time management skills, with no goal expectations, and aggregating time and non-aggregating time to answer correctly are low-performing students. Another very interesting solution, though, is that students who, although understand the content and say that it's clear to me, I understand it, I'm satisfied from the content, but I don't have expectations and I answer wrongly, I am a bad student, low-performing student, which is a surprising finding. The method and these results have very interesting theoretical and practical implications. As I said before, the method complements and extends previous research by offering alternative views on how the measures, the variables used, can be combined to predict performance. The second implication is that learning analytics researchers and practitioners can use FsQCA to make sense of diverse analytics and to take design decisions accordingly for different subgroup populations. Another implication is that we can incorporate data from various activities and modalities and make sense of complex interactions, offering a holistic understanding of the potential of this data technique, analysis technique, in our research field. And of course, there are methodological implications, including the following. First, the method differs from the previous ones by performing configuration analysis to examine asymmetric relationships. And this one is the one that should draw our attention. The method provides the tools for identifying asymmetric relationships which are invisible with other methods. If it's applied with complexity and configuration theory, FsQCA can contribute to creating new models, new theories, and new hypotheses. And combining FsQCA with the traditional variance-based methods, we can gain a deeper insight into learning analytics and can extend previous theories and practices. And this one is very close to what our keynote said in the morning. FsQCA has a quantitative approach, quantifies what has been detected from a qualitative viewpoint. What we sense and understand as the characteristics of low performers and high performance is being quantified in asymmetric relationships. Thank you.
Thank you. So, time for questions. My first one would be, how would you make that actionable? I mean, you have now 3 different dimensions that you analyze, and you have your diagrams of which parameters would kind of give an indication of high performance or low performance. Now, if you think a few steps ahead, you want to make sure that actionable and actually kind of support students based on your findings. What could that look like?
You mean how can I use the results in practice to support my students? And well, actually, the method identifies the relationships. The method itself, FsQCA, is not a method that directly leads to actionable results or something. The basic characteristic of the method, as I said before, is that it identifies different viewpoints, and it bridges qualitative and quantitative approaches. When the teacher or the instructor or whoever has the results, when the results become available, then the human instructor himself must take the decision on what to do and how to intervene with those students. The important thing is that now I have something to rely on and understand how students and why students behave the way they do. Actioning beyond that is something that requires human decision and justification.
Any more questions from the audience? I think a second one I had was, you show the right slide for that. You pick these 3 elements, and you, I assume your analysis method could be applied with different inputs as well. What made you choose exactly these? You might have chosen, instead of response time, you could, for instance, have said, you know, percentage of errors made during training, or, you know, it would be easy to replace some of these parameters and still use your methodology. What made you pick just these?
After the literature review on which parameters have been mostly used to explain performance, we found that beyond the grades themselves, there are some other parameters, including motivational factors, as I said before. And among these parameters, we found that self-regulation is a strong factor, and response times is also used for explaining and predicting performance in many different fields, from intelligent tutoring systems to computerized adaptive testing. And also response times is very easy to measure, to track and compute. So we have in mind to explore different parameters and include different parameters in the model. This is only an exploratory study. In fact, this is our first study in this, with this method in this particular field. So many other parameters are under research right now.
Okay, thank you.
So in the table, you were expressing the importance or the size of effect with the large or small
This one.
Could you say a little bit more about how you determined whether something is this an effect size, or how is this exactly being determined to be either a small peripheral or a core condition?
I couldn't exactly understand the question, please. Sorry.
How is a core or a peripheral condition determined? Like, what is separating those two?
High values, the core effects are high values in this specific variable. When we have high values, for example, the solution A5 here, it says that we have high values in satisfaction from content, we have high values in goal expectation, we have lower values in time management, and these three have an effect on on predicting the outcome. The difference is that the peripheral conditions, their effect is not that much strong. It's lower, but they participate. As in this solution, the response times do not participate at all. They have no effect in this solution, in this specific solution. They participate in the other four solutions, however, response times.
If I may add to that, so let's take one step back on the analysis and the methodology. It's something that it wasn't mentioned in the presentation because it gets maybe too technical, but it's good that you brought it up. So this is here based on a set theory. So what we are identifying is necessary and sufficient conditions for the outcome. So we are not looking for the most significant factor in a solution, right? We are trying to go beyond that, right? So here, when FsQCA could be also, we could say that this is actually an analysis of sufficiency, which means that we are looking into different combinations of factors. Okay, we said that, but which of these factors are sufficient to have high performance? And before doing that, we could also do an analysis of necessity. So the question would be, is there any of these factors necessary to have high performance? And we did that, but it was not part of the paper since we have a limitation pages anyway. But none of these factors is necessary for high performance, which means that they could be missing, they could be present or absent, and still have high performance. So it's not a net effects question, right?
I don't see further questions, so that concludes the session. Thanks again.